All right, guys, I said that we'd do the 11-2 practice problems, or the 11-2 apply, sorry, not practice problems. I already sent some of those out. So I'm setting up number one. I kind of have it set up. It's a two-parter because we had to find grams of water and grams of iron 3 chloride for this, given that we're starting off with our reactant side with iron 3 carbonate. We have 217 grams of that. So again, we got to know molar conversions. We have to have our balanced equation because this middle conversion, and most of the time, your middle conversion on all of them is always going to deal with that molar ratio between the reactant and product side, or reactant side or product side, depending on what you're going to. So I'm going to do water first and then iron 3 chloride. I know you might have did it the other way. It doesn't matter. So we have 217 grams of iron 3 carbonate, and we have to turn that into moles. So 1 mole of FeCO3 is 292 grams of Fe2CO3. And how did we get the 292? We look on our periodic table. We add up all the parts of iron 3 carbonate, and it adds up to 292 grams. That gets me my moles. Now, once I get to moles, I can look at my balanced equation and say, hey, I need water. So I know that 3 moles of water are equal to 1 mole of my iron 3 carbonate. Okay, put my 2 there. Those guys cancel out. Those grams cancel out there. And then I just need to convert moles of water into grams of water. We know that there's 18 grams of water in every 1 mole of water. So those cancel out. We have 3 sig figs in the problem, so our answer has to be 3 sig figs. So you get 40.1 grams. Okay. Second part is converting it to iron 3 chloride. The first step is exactly the same, which is kind of nice. You do it once, you just get to copy it. And that's 292 grams Fe3. Those cancel out. Now here we got to change over because we want to get FeCl3, and that's 2 moles of iron 3 chloride for every 1 mole of iron carbonate, iron 3 carbonate. Those cancel out. 1 mole of iron 3 chloride is equal to, it's going to give us a decimal number on this one, 162.5 grams of iron 3 chloride. Moles cancel out. Again, why is that a 0.5? Because chlorine is 35.5, and that's what we use for that one. Should come up with an answer of 242 grams of iron 3 chloride. Okay, that takes us to question number 2, which is looking at a volume and turning it into grams of hydrochloric acid. So it says you have 100 liters of carbon dioxide, and we want to turn that into how many grams of hydrogen chloride. It may be hydrochloric acid, they didn't tell us. Hydrogen chloride to create this compound. And it is an acid, but let's just call it hydrogen chloride the way they have it kind of given to us. So I'm just going to start off with number 2. I'm going to just start off with the setup. 100 liters. How many sig figs is that? There's a decimal there. That decimal tells us that this is 3 sig figs exactly. CO2. First conversion is let's turn that into moles of CO2. To turn that into moles of CO2, I know from our mole diagram that there's 22.4 liters of CO2 in every mole of CO2. So that gets rid of that one. I can now convert my moles of CO2 into moles of hydrochloric acid, or moles of hydrogen chloride. So I know that 3 moles of CO2 from this side of my equation is going to be equivalent to 6 moles of, those cancel out. Now, you could cancel out the 3 and the 6 if you want to. I usually suggest to my students not to do that until you're further along and playing around with these diagrams and doing this stoichiometry. So just leave it the way it is. The last thing is let's turn this into grams of HCl per 1 mole of HCl. And 35.5 plus 1 is 36.5. Those cancel out. I've canceled everything else out. I go 100 divided by 22.4 times 6 divided by 3 times 36.5. And 3 sig figs in your answer. You should tell me that you're going to get 326 grams of HCl. Circle it. That's number 2. Okay. That takes us to number 3. Another 2-stepper, which is saying it wants to know how much iron carbonate are we going to get if we have a certain amount of, I think, iron 3 chloride is what we're starting with on this one. Yes. We want to start with hydrochloric acid and how much of this I'm going to use. So it's a reactant to reactant side one. So I'm just going to start off with on number 3, the 5.0 times 10 to the 25th units. And again, they shouldn't use units here for HCl because it is actually a molecular compound. And we got to convert that, the first thing, into units, or actually into actual units of our iron 3 carbonate. So to do that, we know that 1 mole of HCl is 6.02 times 10 to the 23rd units of HCl. Let's just keep them the same. Okay. Now I can compare my molar units. I got 1 mole, so 6 moles of HCl is 1 mole of Fe2CO3. Okay, and then we need to turn this into units of that, so we have to use Avogadro's number again. 1 mole Fe2CO3, 6.02 times 10 to the 23rd units of Fe2CO3. Now, we can cancel things out here. Yep, those cancel out, those cancel out. What's also really nice is, guess what else cancels out? These two right here. I can cancel out those Avogadro numbers, and I don't have to plug those into my calculator. Now all I got to do is take 5.0 times 10 to the 25th and divide it by 6. I can make doing math easy on myself if I write out my problem. And your first answer should be 8.3 times 10 to the 24th units of Fe2. So that should be your first one. Now, that's not what the answer wants. It wants the units, and then it says, okay, hey, how many grams is that? So now we got to take our 8.3 times 10 to the 24th units and turn these into grams. And I'm going to shorten this up, units, because of just to speed up time. You guys should have Fe2CO3 there. We know that this is going to be 6.02 times 10 to the 23rd units of Fe2CO3. And that's 1 mole of Fe2CO3. And then we got to change that into grams of Fe2CO3. 1 mole Fe2CO3. Okay, and again, where do I know the grams is? I look at problem number 1. It's 292. I did it once. I don't need to do the math again. Cancel those out. Units cancel out. I plug and chug, and you should come out with, I can only have 2 sig figs. 2 sig figs. This comes out to be 4,047 grams. I think if I can read my own handwriting there. And this actually turns into 4.0 times 10 to the 3rd grams of Fe2CO3. Bingo. And that's number 3. And then on number 4, you had to explain to me why when you add up the coefficients, I got 1 plus 6 is 7, but over here I got 6 plus 2 is 8. Does that break the first law of thermodynamics? The law of conservation of mass? No, because I have the same number of atoms on both sides, atoms of all these parts. That's why we balanced it. Just because over here I have 2 reactants, over here I have 3 products. I just have the atoms spread over more units, over more other particles, molecules. Okay? So, no, we didn't break any rules. And that's a common problem, or a common thing you'll see in some of your problems. They'll say, hey, did you are you really following the first law of thermodynamics? Yeah. As long as everything is balanced. As soon as you balance that equation, you are following the law of conservation of mass. You're following the first law of thermodynamics. So number 4 is just you recognizing that, hey, when a chemical reaction does occur, I might get more products. Heck, you might only get 1 product. If it was a synthesis problem, we would go from 2 to 1. Or maybe we went from 3 to 2. Okay? Whatever happens. As long as it's balanced, you're still always going to follow that law. And if you didn't balance it, you can't do any of this math. None of this would work. So that is 11.2 applied, done really quickly, kind of sloppily, but you can look at it. You can check your work against it. If you have any questions, please email me right away. I get back to people that email me. I'll talk to you later.